Alright, so today we're going to talk about exact values, day 2. It's the same exact concept that day 1 was, it's just more practice on it. So this sentence says, you will be expected to find exact values of all 40, 5, 30, and 60 degree reference angles. And we could do radians and degrees, so we'll rationalize when necessary. These are the special rights that we were doing in the start of the year. So that's why we do these reference angles, is because we know the ratios of the special right triangles. So if we start, this first example and second example for that matter is in degrees. So we're going to start today in degrees. So sine of 120 degrees. So when you're thinking about this problem, first you have to know where 120 degrees is. You cannot start until you know where 120 degrees is. So do this how you will. I mean, we've talked about many ways to do this. You can either just count, but a lot of y'all are just really familiar with this represents 180, and if this is 90, then 120 is somewhere over here. So I'm going to be in quadrant 2. I'm going to draw quadrant 2. And the point of doing this is to say, well, this represents 120 degrees, as in like right here is the 120 degree. But I'm not really concerned about the standard angle. Well, I shouldn't say I'm not concerned, but the standard angle is what tells you where you are at, but it does not tell you your triangle. Your triangle is going to get formed with the reference angle to the closest x-axis. So if this represents the 120 degree terminal side, if I go straight down, this is the triangle that I'm going to be looking at. So it's just about saying, well, this is where I'm at, this is the triangle that I formed. If I'm using this as my terminal side, I can identify my reference angle as 120 is from here to here, therefore this is 60. So if this is 60, I can say, well, across 60 is the square root of 3. I'm talking about my special rights now. Square root of 3. Across the 30 is the 1, and across the 90 is the 2. I check for negatives, and so a negative belongs with the x because you had to go in the negative x direction. Okay? So this is the triangle represented for 120 degrees. I haven't even touched the fact that I'm talking about sine yet. Now I say, well, the answer to this is going to equal the ratio O over H. So my ratio is root 3, my hypotenuse is 2. So root 3 over 2 is the answer to this problem. Okay, and that's example A. So let's do example B. In example B, we have secant of negative 135 degrees. So secant of negative 135 degrees. Once again, you do have to determine where this is going to be. Since this is a negative angle, we're going to go in that clockwise direction. So if we're going in the clockwise direction, it's this way. I need to go negative 135. So this represents negative 90. This represents negative 180. So it's somewhere here. So this represents negative 135 degrees. But that's not a triangle that I want to use. You always need to use the triangle to the closest x-axis. So the triangle that I'm going to use is I'm going to take this terminal side and I'm going to go to the closest x-axis, which is here. So this will actually be the triangle that I'm going to use. And if this is negative 135 degrees, if I'm going to end at 180, the reference angle is 45. Remember that the reference angle is always positive, so it doesn't matter that it's actually going in the negative direction at this point. You're just talking about the angle it creates is 45 degrees. So across the 45 is 1, across the other 45 is 1, and across the 90 is root 2. we check for negatives, we actually find that both of these numbers will be negative, -1 and -1, because you went left and down here. All right, so this is the triangle. Now I answer the question. Secant of -135. So secant, if you want to remind yourself, is it's SOHCAHTOA, and then this is cosecant, this is secant, and this is cotangent. So secant is the reciprocal of cosine, so this is h over a. So my h is √2, my a is -1. So √2 over -1. I don't like answers with negatives in the denominator, so I'll say -√2. All right, let's keep going. Cosecant of 4 pi over 3. So, however you want to do this problem, on last lesson I talked about counting. If you want to count, you can't use 4 pi over 3. You need to use a common denominator 2 over 2, so you're going to use 8 pi over 6. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. So you're in quadrant 3. Now if you used a different method, that's fine. You could have also said, well, I know that this is 3 pi over 3, so 4 pi over 3 is right here, and it's going to make this angle. You should get the same thing no matter which way you go about it. So this is what represents 4 pi over 3. But I don't care about that whole big angle. I want to know about the triangle it creates. So if I look at this triangle right here, if this was 4 pi over 3, this is 3 pi over 3, then the angle is single pi over 3, which is 60 degrees. So across 60 is √3, across 30 is 1, and across 90 is 2. Check for negatives is -1 and -√3. And cosecant is h over o. So h is 2, o is -√3. I'll rationalize. And I'm also going to put that negative sign not in the denominator. So -2√3 over 3 is a final answer here. All right, cotangent of 5 pi over 4. So 5 pi over 4, now let's do it the other method I was talking about. This, you know, is 4 pi over 4, so 5 pi over 4 is here. Or you can count 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. These aren't different ways, they're just maybe mentally how you have learned how to process this, but it is the same exact thing. And so if that was 5 pi over 4, this represents single pi over 4, which is 45 degrees. So across 45 is 1, 1, √2. If I check for negatives, this is negative and this is negative. And to answer the question, cotangent is a over o. So a is -1, o is -1, which actually leaves +1 as an answer. All right. Quadrantal angles, these are the axis angles. So when you talk about sine, you talk about opposite over hypotenuse. And when you're doing the opposite on any triangle, when you do opposite, it's your height here. So if this is your height, then it's really all about your height that's really going to be important. That's what's going to tell you if it's negative or positive. And cosine is adjacent over hypotenuse, so this is going to be your side-to-side movement. And tangent is O over A, so that's going to be both height and side. And I tried to kind of go over this example in class, but when you're on the quadrantal angles, you kind of imagine if you were, let's do this one, if this was your triangle instead of actually on the quadrantal angle, then your hypotenuse is actually going to be laying right on top of your movement. And now it doesn't matter if it's going on the negative x direction or if it was going up here. Either way, that hypotenuse is kind of getting to be on top of the movement. So it's really just about saying, did I go up as positive height, down as negative height, left as negative adjacent, or right as positive adjacent? Okay, so sine of 3 pi over 2, for instance. So 3 pi over 2 is, this is pi over 2, pi, 3 pi over 2. So that's right here. So you can see that your movement involves going down 1. Or it doesn't really matter, but you went down. So your opposite is going to be negative. And we just kind of assume that it's 1 here. If your opposite is negative 1, then your hypotenuse is positive 1. But your adjacent is 0. So sine is opposite over hypotenuse, so that's negative 1. Okay. Cosecant is hypotenuse over opposite, so that's also negative 1. Alright, cosine of 3 pi over 2. Now cosine is adjacent over hypotenuse. This is still 3 pi over 2, so it's still right here. Now let's go through this again. You went down, so that represents opposite of negative 1. Your hypotenuse is right on top of it, but your hypotenuse is always positive, and your adjacent is going to be 0. So this is adjacent over hypotenuse, so 0 over 1 is 0. Secant is 1 over 0, which is undefined. Alright, tangent of pi, so pi is here. So now you've gone adjacently backwards, but you haven't gone up or down at all. So now your adjacent is negative 1 and your opposite and your hypotenuse is the same, so 1. So this is opposite over adjacent, so 0 over negative 1 is 0. Okay, so y'all can see if you can do the rest of this. I also want to talk about a trick. And the trick involves a table with sine, cosine, tangent, and then you go in order of the quadrantal angles. So you start with 0, 90, 180, 270. So you have to have this saying, and the saying is O, I, O, I, O, U, O, I don't, O, I don't, O, U. So what that tells you is that sine of 0 is 0, cosine of 0 is 1, tangent of 0 is 0. So it's just a way for you to kind of know these without being able to do them on the graph. If you prefer to do this method, that's perfectly fine. Pause it right now if you need to copy that down still. Alright, so if we just go jump to the challenge, I do want to talk about this. So it says cosecant of 3 pi over 2. So if I do 3 pi over 2, that's right here. And cosecant is going to be h over o. And since your opposite is going down, this is going to be -1. So the answer to cosecant of 3 pi over 2 is -1. But then I have to do plus secant of pi. So now I'm going to work on secant of pi. So secant of pi, this is where pi is, and secant is h over a. So your h is still 1, and your a is now, because you went adjacently backwards, another -1. So this represents secant of pi, and I still have to do plus cosine of 0. So lastly, 0 is when you start. Cosine is adjacent over hypotenuse. You did move adjacently to the positive direction, so now this is +1. So -1 plus -1 plus 1, you could consider these two as canceling each other out, is equal to -1. Final answer. And that's it for today's lesson.